as an overview, so let me just talk about this. So the way that the demonstrator works is that it's a set of Docker containers which are orchestrated with Docker Compose and is meant to represent sort of logical or physical components. And so it has a router in a container which routes between three networks. So there's an internal network and an external network, and then a third network called mirror, where the traffic between those two is mirrored to this third internal network, private network. And on that network sits a bro node or a Zeek node, an Elasticsearch cluster, and a MISP instance. And the idea is that you use a small amount of traffic and then use that to trace the processes that we're looking at here. Okay, so this has been running for a while, gathering data, although not much is happening. And so all of the traffic that records is contained within the Docker Docker cluster. So the VM we have, which actually, let me just pass these around. So if I passed in a couple in that direction. So if you want to take a copy. This is all pre-built within the VM. We can start by having a look at the log output using the Docker Compose. Lets you sort of see what the standard out is for each of the components. Okay, so you can see this is the output of the cluster. Let's just stop that.
Sorry, I don't get. So the PocketSOC local, what is it? It's
so these are just wrapper scripts. So yeah. So the whole
each of the
each of these is our container.
Okay, and what and between what was the thinking when you put each of these in a Docker container? What is the final?
So the goal.
The
goal of this is primarily a demonstration tool. One of the things that came from the last workshop was being able to visualize what happens when you have traffic and then how it goes through the different processes, so that you can flag it and identify it and see what happens, particularly for people that hadn't seen it before. And so the primary goal is as a demonstration tool. So for example, I wouldn't say you should take this and deploy it on your site. It's an aid for this purpose in particular.
It can also be useful for people which are new to rather get around it, to see how the different components integrate one with each other.
Okay. Okay, so as we start it up, you can see each of the components starting up. And so the idea is that you have a number of data sources. So there's an Apache source, which serves static content, and a Flask source, which serves dynamic content. So you can see it starting up. Okay. So first thing we can do is have a look at the interface of MISP, which if you haven't seen it, looks like this. This one is pre-configured with a new password. And so the first thing we see here is that there are no events, and what we'll do in this demonstration is create an event to let you see that interface. And in particular, we can also, at the moment, we have one user, which is the admin user, and we see that, let me increase the size, they have an auth key which is used to access the API. So there's an API, a Python API, or Python client to that API that you can use to work with MISP without having the web application deployed. So if we put that up there, we can also see what our Kibana instance is seeing. Okay, so start again. So you can see this is the output of the Zeek IDS, and you can see that it's now seeing traffic. Let's refresh that. You see there's a break in the period where I had it turned off. So hopefully that will update soon. Yeah. Okay, so we can take a look at one of these messages. And so, for example, so one of the things that Bro or Zeek rather will do is, as you add scripts, you can tell it to analyze for different kinds of data. So, for example, there's a Bro files type, which will look at the files that have been transferred, gather file hashes and that kind of thing. So, for example, this file that's been downloaded has a SHA-1 hash and MD5 hash, which you can configure when you deploy it. And so we'll use that here. And in fact, what this is doing is the Bro node or the Zeek node polling the MISP instance for its threat intelligence data. And the reason why I looked at the auth key was to note that if we look at the Bro node briefly, Good. Again. So as much as possible, this demo uses the components and the instructions that are in the documentation that I mentioned before. And so in particular, this is the script that will download all of the threat intelligence from the MISP instance. And we note that that is not the correct key. Specifically, so that, or in this case, so that we can say, here, if we go back to our Cabana, which is taking the output of the Bro node or the Zeek node, we can search for, so we do type equals Bro HTTP. So this is now only the HTTP protocol traffic that it's seen. And we want to look at the status codes. So you see that everything that it's recording is giving you a 403 because it's forbidden. And so what you can see is that if you go back to the, well, first of all, if you go back to the MISP node and you record the auth key, and we put that into the script. So this runs every minute. And what we should see here, hopefully, in about 15 seconds or so. So what we should see is that this updates with the 200. Yeah, so you can see whatever's happening, it's now started to detect that instead. And so, that's an example of, you can look for particular kinds of behavior. So then the other example I was going to show was, in this context, was, as I mentioned, if we remove that, we can look at Bro files. Yeah. So as I mentioned, you can look for particular file hashes. So if we go back to our interface here, we have one, and come out of the IDS, we have one client container which is set up to be, a person inside a network doing something. And so in this case, this person is going to curl his web server, which just gives some static output. But what we can do is see that this has some hash. So let's copy that. And so what we're going to do now is identify that using MISP as malicious behavior. So let's minimize that and go back to our MISP interface. And so now we can go back to our main screen, and we want to add an event with a particular attribute. So we say add an event, and this is going to be given a particular distribution. So you can set how far a particular share will go. So you can either say it's your organization only, so it will be held local, or this community, or friends of friends. And so you can set how that degrades. And so if we just say this organization only, doesn't really matter. In this case, we'll say it's medium. You can set whether this is an initial analysis, whether it's ongoing or completed. We can say it's a workshop demo and add that. And so then this is an event which has now been generated, and we now have a list of attributes for this event that another site could use to recognize the malicious traffic. And so what we can do is to add an attribute. And what we'll say is this is payload delivery, and it's a SHA-1 sum in this case, and we give it the value. And so there's one other box you need to check, which is the intrusion detection system, and that flag is set so that you can choose whether or not to import that into an IDS. It may be that there's an event that you see that you don't want to trigger on. For example, if you see many events with Google.com as involved parties, you don't want to act on that because there's too many of them, or Microsoft or anything like that. So what we want to do now is submit that attribute. And so now we have one attribute to this event, which has a fingerprint. And then the last thing we want to do is publish the event, because now we've finished working on it and we want to publish it to make it available. Okay, so now we can do a few things. And in fact, one thing we can do is so if we look at the SHA-1 sum and the TX and RX. So one thing is 172.20.0.20 is the MISP node. And so what you can see is that the information being sent from the MISP node in the pull MISP script changes now that it's got some different information. So you can see that the contents of that have changed. But what we can also do is, if I go back here and I dig the Apache node, so that's 172.19.02, we can look here and see that's the file hash for the payload that we've been downloading, which is the static content. And so now we can look at so what's called the bro intel type, which currently doesn't have any data because in this time frame it hasn't seen it yet, because it only recognizes it as malicious after we've loaded the event into MISP. So now what we can do is get this to grab this a few times. Okay, so now we are downloading that payload, and we come back here, and hopefully, well, while that's updating, we can open another window, and actually you can just see it updating in the background there. But as another view of this, if we have this chance to have a look at the configuration of the Bro node, what we can do is have a look at the logs that you generate. In this case, it's stored in alt-bro logs. The format that uses, so it stores these in date directories, and the current ones are in current. This is populated because it's the same install I've used a few times. And so you can see here a number of logs. And each of these logs, so there are some special logs looking at capture loss and other things like that. But for example, you can see the connection log, which tells you about every connection that it sees. And I can show you that run. And so this is all the traffic data that Bro is seeing. You'll note that the output of this is in JSON format. There's a switch inside Bro, or Zeek, I should start calling it, sorry, which lets you output in JSON format, which we'll see when we talk about integrations, makes ingesting this data into Elasticsearch much easier because it makes so we use Logstash, pipeline is much more straightforward. Because it's already in JSON format. And so you can see here the same information which you're seeing in Kibana, the timestamp, the originating post, the port information, the size of the response, all that kind of thing. But in particular, what we should be able to see now is, well, first of all, what let me show you is if we look at our script to pull the event data, we see that it's populating a file called testdata.txt. And so if we cat that, sorry, yes. You can see the output of the event that we just populated. Okay, so you can see, so there's a note for the type of for the attribute itself, which is the file hash, the type of IOC, a reference with a reference ID, where it came from, name of the event, and the MISP instance that it came from. And so what you would see in this case is that Intel file would then be populated with all the relevant events that you wanted to look at. And then you can change how you work with that, how many of those you hold at any one time. Okay, so that's the same information that we saw in MISP is now being pulled down to the bro node, or the Zeek node. And so now what we can do is, if we go back to our logs, so to show you the other view of this, if we now look at our Intel log, in this configuration it's set up to look at the Intel log, you can see now all of the sightings of that file hash, which obviously is updating continuously because we're still curling this. So if I stop that and bring this back up again, we should see that, of course, now it stops updating. And now if we go back and look at our Kibana, and what we've done is just to search for bro Intel, and what you can see is that you start to see settings of this particular traffic, which starts and then at some point later comes to an end. Okay, so that's shown starting from originating some traffic and then loading some payload with some file hash, and then seeing that both in the Zeek logs and also in the bro Intel logs, having identified that event as malicious. And then the next thing you could do in this case would be to configure something which is possible but not currently configured, is that you can use a tool called ElastAlert, which looks at thresholds within Elasticsearch and monitors for example, the first time you see a new IP, or you see a particular rate of change of a particular value, and then acting on that can trigger an alert to an email or a text or a messenger service or whatever. So that is the configuration for that is in the VM, but not turned on because that requires the particular form of communication you want to use. So one thing, that's a tour around looking at the Zeek source. The other source is looking at NetFlow data. And so we have configured on the client, and I'm just going to say now that this was added more recently, so it is a bit more fragile in terms of working. So this might be something you need to work on, and depending how we go. But if we look at the client, and we look at the running processes, you can see, so we're currently using PMACD, which is a tool that's used, so it's used for network accounting, but one of the jobs that it does is to convert NetFlow data of various kinds between different versions. So it can take network data and generate NetFlow or SFlow. It can convert from SFlow to NetFlow. It's a useful tool. And the way we have it configured here is that it's generating NetFlow from the client and then sending that to a NetFlow collector. And the way that we have this configured is that, so we have our Dockerized Elasticsearch cluster, and for each pipeline that we use, so there's a Logstash pipeline for Zeek, which, as I said, uses the JSON file output. It also has another container with another Logstash pipeline, which, to steal a tiny bit of Greg's thunder, is I think not dissimilar to how you do it. So it's not, and so effectively there for every Logstash pipeline you just have another container, so it makes deployment easier. You don't have to worry about multi-pipelines in this case. And so we have another Logstash pipeline which uses a piece of software called Elastaflow, which some of you may have come across before, which is a tool to, or a set of pipelines to ingest NetFlow of many different versions and SFlow of many different versions, and then ingest that into Elasticsearch. So what we'll do now is have a look. One thing to note about this is that these tools are typically not designed to be turned on and off frequently, and are designed to start up and then run for some time. Not least because Logstash is Java and takes some time to start up. And so hopefully we've left this long enough to pull in some data. So these are a set of dashboards which are part of Elastaflow. So you import those, and then you can use them. You can use them as part of your deployment. These are not ones that we wrote internally. So making use of their development. And so what we can do is if we choose one of these. So for example, if we look at the overview, what you can see is a set of information which has now been gathered by Elastaflow. So this is a visualization of NetFlow data. And for example, you can see a set of servers and clients. So you can see this is the Apache node. This is one of the Elastic nodes. 100 is the router. It appears in several places, also where maybe it shouldn't, just because of the network configuration. You can see, of course, there's IPv6 data, which, as a rule, if you're not monitoring IPv6, you should be, because it's there whether you expect it to or not. You can see that it's identified the different types of traffic. So there's some ICMP. There's a set of DNS data. The nice thing here is that there was no configuration in that. It just you fired up the NetFlow generator on the client node, and then the NetFlow was ingested, and then Elastaflow has done the work to parse that out and to show that in different places. You can see the different parts there. So this is really all. I was going to show about this because this is a relatively new addition. So this has been added in the last sort of couple of weeks. So it's more of an existence thing than anything else. But what we can do is, if we now go back and switch our pattern to Elastaflow, why is that not showing anything? Because there's no bro intel in Elastaflow. Still not. Okay, so I'm not quite sure why that's not showing up there where the dashboard is. Yeah. Well, that's. Sorry.
I was thinking you didn't have enough time.
Yeah. So as I say, so that's a bit that's a recent addition. So, the thing which was where I was getting to with working with this, and a question for us more generally is, if you look at the information you get from Elastaflow, which has a particular schema, and you look at the information you get from Zeek, which might have a particular schema, the next question is to say, so how do you correlate that information? How do you combine the information from different data sources? And looking at something like normalizing your schema. And so in that, something which I'm hoping we can do in the future, although we haven't, although I'm hoping we can do more of in the future, is so Oxcert, the Oxford CSERT, are doing a very nice piece of work in integrating all of their data sources into one place, into one Elasticsearch cluster. And their plans, as I understand it, is to again, as you're saying, so make that open source so that we can sort of have access to their workflows, and also they've been doing some interesting work on. So Elastic has a Elastic Common Schema, which is the idea is that if you have a number of records which show the same thing, you want it to have the same tag in each case. And so Elasticsearch has the Elasticsearch Common Schema, and so the Oxford guys have been expanding that and extending that. And I think they're also going to provide that. So that might be something interesting we can look at in terms of normalizing different data sources so that you can then do some correlation within it. And I'm hoping that some of those guys will come along at some point during the week so that we can say hello. So that's really kind of getting to the point that I wanted to make with the demo. I had hoped to have a few more slides at the beginning to go through the network diagram, and so I might actually just do that at some point and then steal some time back to show that to you. But hopefully that gave you some idea of the sort of thing that you can do on a very small scale. And so I guess, are there any questions or thoughts or comments or things that puzzle you or anything like that? In specific, not in general.
So is this a different tool, like this Holocene? What was that?
So it's written by a guy called Rob Cowart, and his company is Cosener, or how you call that word. So yeah, so his security company is that's what that is, and effectively this was written after he published quite a nice YouTube video on analyzing that flow and how you might ingest it into Elastic, and I think the reaction to that was good, and so he decided to to write it up, and so then that's what came of that.
How is this licensed? So what license the Elasticflow?
I do not know the answer to that question. Let me find out for you. I will find out for you live.
I found the project in GitHub.
Mm-hmm.
On this page.
Yeah.
So it's public license.
So I mean, it's. I think I understand that he has. So there are actually. Let me just show it to you. Again, hopefully the guys remotely you can see this now. So what you can see here is. Okay, so I guess he's got a Patreon now for looking at this. It is a self-defined public license. Yeah. So you can look at this, and so for example, you have a set of JSON for the different dashboards. He's generally doing quite a nice job of shipping them for various versions. He's not done one for 6.5, which I think is the current version. I get a sense from something someone else said. So actually, Vim was noting that he's maybe not happy about having to update it for every individual version just because it's a pain with Java. But hopefully that will continue. And certainly, in fact, sorry, I hadn't checked this in the last 2 days. So
I've been running it 6.5.4 for
yeah. So one of the things, and if people are interested, I'd be happy to go through the more detailed configuration within the Docker setup, but I'm using two other external products, one of which is MISP Docker, which is a Dockerized MISP install, and the other one is Docker Elk, which is a Docker Elastic's containerized install, which is nice because you can then pick out exactly which version. So, yeah, but yeah, so actually, it is being updated quite frequently. One thing I would note is, and so also you can see, if you're looking here, where would I find it? So yeah, so these are all the different, so these are all the different pipelines, and so you can see there's IPv4, IPv6, there's NetFlow, there's IPFix, there's SFlow. These are all then opened up on different port numbers. A story I'll tell against myself is that originally I tried this working with SFlow with this, and then when I switched to NetFlow it wasn't working because you need to make sure you fire at the right port. But it means that that's already configured for you, which is quite nice. So Elastiflow is a nice tool. One thing is, if I can find it, and this is in some ways eating into some of the integration stuff, so we'll come back to this, because I don't want to eat the lunch of the rest of the sessions. One thing is that it does require a fair bit of memory. So this container is set to use 2 gigabytes, and it's got a tiny amount of traffic. They recommend more than that, and there's a chart somewhere in here which I can't find offhand. So that's one. If you're using Elastiflow, then something you need to consider is making sure that your host has enough memory to work with.